The question says that a car weighs 1800 kg. The distance between its front and back axle is 1.8 meter. If the center of gravity is 1.05 meter behind the front axle, determine the force exerted by the level ground on each front wheel and each back wheel. So this is the symbolic representation of a car, and this is the front axle and this is the rear axle. Now I have numbered the wheels in clockwise direction, that is 1, 2, 3 and 4, and the center of mass is located by this point G, and it is at a distance of 1.05 meter from the front axle. So we have to find out what is the reaction force that is being applied on the wheels, all the wheels, now front wheel and the rear wheel. So from the equilibrium point of view, we know that the vehicle is not going up or down, so it is in equilibrium, and that is the forces are balanced. So the reaction force must be equal to the weight of the car. So here R1 plus R2 plus R3 plus R4 are the reaction forces of the wheels, and that should be equal to the weight of the car body. So this is the first relation that we are getting. Now since the car is also not rotating, so the moment must also be 0. So taking moment about this point G, that is the center of gravity, we will get this front reaction from the first two wheels will be trying to rotate the car clockwise. So if we see the car in this way in the side view, so this is the front axle and this is the rear axle, and the point G is over here. Now when there is a reaction from the front wheel, so it will try to rotate the car in clockwise direction, that is why minus sign is over here, and the reaction from the rear wheel will try to rotate the car in anti-clockwise direction, so it is plus. Now this should also sum up to 0. Now assuming that the car is symmetrical, that is the reaction in wheel 1 is equals to reaction in wheel 2, and also reaction in wheel 4 is equals to reaction in wheel 3. We will get this relation from 1, that is R1 plus R3 equals to 900 times 9.8, because of the symmetry condition, only half of the weight would be acting on each of the wheels, that is each half of the wheels. Now from relation 2 we will get this equation from the moment equation. Now from this we can relate relation 1 with reaction 1 with reaction 3 using this relation. Now substituting this relation of reaction 1 in this equation number 3, we will get R3 times 1.8 by 1.05 equals to 900 times 9.8. We will give us the reaction in third wheel to be of 5145 Newton and reaction in first wheel be of 3675 Newton. So we see that each of the wheel from the front wheel 1 and 2 will be having this reaction force, that is wheel number 1 and 2 would be facing this reaction, and wheel number 3 and 4 will have a reaction of 5145 Newton. Thank you.